So my name is Lindsay and I work at the University of Western Australia in the Centre for Exploration Targeting in the School of Earth Sciences. So the research I'm undertaking is using geophysics to explore the configuration of the Earth's crust. Geophysics is interesting to the public because it's a natural field that the Earth permeates, as well as the fact that we can use it to explore for important mineral deposits called E-minerals, ones associated with electric cars and lithium-ion batteries. All these things benefit from some regional scale geophysical exploration to find out which regions explorers should actually spend their time looking at. Our partners for this are the Minerals Research Institute of Western Australia. We're also supported by the Geological Survey of Western Australia, and our industry partner is Gold Road. So the problem is, where do we go to start exploring for these deposits? We can use data to run something called an inversion, which is the expensive bit, I guess, when talking about computation. This is why we need the Pawsey Supercomputing Centre. The memory requirements are very high, and the process, if run on your standard computer, would probably take weeks and would probably fail as well. On Magnus, the models that we're running takes about 20 minutes. This is an iterative process, so it tests one set of parameters, sees if it works. If it's acceptable, then it moves on to another set of parameters, tests them out, and it iterates through. And it could be up to about 120 different steps or iterations through the process. So I've run probably about 40 or 50 inversions to get a good understanding of what the different parameters do, what effect it has on the resulting model, and assessing them with my eye to see if they're actually geologically feasible. The reason Pawsey was chosen was because it was a supported computing centre. It allowed us to use eScript. It also allows us to scale our inversions, so we can do small ones, big ones, even enormous ones. Alan Aitken has produced an inversion of the entire continent of Australia, which was quite a feat, and Magnus managed to do it without too much issue. They also offer all the storage and visualization capabilities as well, which is a nice feature that the commercial options don't often provide. Being able to produce these models at a scale, or at a resolution, I should say, that is useful for mineral exploration, I think is a key thing for the geosciences, but also in our case to output large models as well is really important. And having that all in the same place cuts down on a lot of time of input-output, sending things across large networks. Data set doesn't really sit on my laptop anymore, it sits on a server somewhere. We write some code, and then it is processed at Pawsey, and we get the model, we just get to look at it, and it's a lot smoother. What makes Pawsey awesome is that we can pretty much throw whatever we like at it, and it manages to handle the size of jobs, big or small. I don't think we've ever come up with a model that it hasn't been able to handle. I guess that's one of our challenges, is to try and break it, but it's always been, it's always managed to deal with the models that we deal with.